Hello everyone, and welcome to see how Indiegogo built a 360 data view with Looker and AWS. My name is Srinivas Kesanapalli, Partner Solution Architect, Data and Analytics, Amazon Web Services, and I will be your host and moderator for today's webinar. Today's agenda is we'll go over how Indiegogo analyst teams built a common data dictionary with Looker, a modern business intelligence and data exploration platform hosted on Amazon EC2, and Amazon Redshift, a fully managed cloud data warehouse from Amazon. We'll start with the introduction with the data analytics at Amazon Web Services Inc. And Looker will go over, get the full picture of your data, and Indiegogo will walk you through how they enabled analysts to perform high value tasks. And we open for Q&A. In addition to my interactive presentation on data and analytics at Amazon Web Services, today we'll hear from Daniel Means, Chief Data Evangelist at Looker, Caitlin Moorman, Senior Director of Insight and Analytics at Indiegogo. Today's analytical needs have been evolved. Leaders are organizations defined by their efficiency of data capture, data accessibility, and timeliness of data. Data now is more valuable than ever before. So leaders who can quickly find data and capture the data from wide variety of sources in variety of data formats and make it available to business professionals and other decision makers in a timely manner have a 9% revenue growth advantage over followers. And there is more data now than ever before. Data coming from mobile devices, social media feeds, computer systems, remote monitoring devices, autonomous vehicles, etc. So as more and more standalone devices give way to digital devices that are generating vast amounts of data that is growing greater than 10 times every 5 years, data warehouses should have the capability to scale up to 1000 times and live for 15 years. When you look at the innovation in data analytic marketplace in the past 11 years, starting with Hadoop, Elasticsearch, Presto, Spark, etc., there are more ways to analyze the data now than before. And there are more people working with the data and are interested in learning deeper insights from the data that is stored in their systems. Along with this democratization of data, this needs better data governance and security. All this data from new sources open up new vulnerabilities to private and sensitive information. And there is a significant gap between the amount of data being produced today that requires security and the amount of data that is actually being secured. The traditional data warehouses, they're not able to keep up with these new emerging use cases and trends. As data warehouses grow with mission critical data, ROT, which we call redundant, obsolete, or trial data, and dark data, data retained for compliance purposes and other reasons. As they grow, the traditional data warehouses become slow and expensive, difficult to scale both horizontally and vertically. They lack the flexibility to work with other analytical engines such as Hadoop, Elasticsearch, Presto, and Spark. They do not have the capability to handle data variety and cannot work with open data formats such as Apache Arc, Parquet, and JSON file formats. And they cannot able to handle growing data analyst user base and make it very difficult to implement data governance and security controls. Your choice of data warehouse affects more than just your data warehousing workloads. As you look at this chart, the today's broken view of data warehouse, we have structured data in data warehouse, unstructured data in data lake, for machine learning workloads, and a mix of structured data from data warehouse and data lake for real-time and ad hoc data analysis. Amazon Redshift solves this broken view. Amazon Redshift is a cloud data warehouse which is the most popular with 10,000 customers and growing and processes 2 exabytes of customer data per day. It is 2 times faster than number 2 cloud data warehouse and up to 75% cheaper than number 2 cloud data warehouse and is integrated with the data lake that enables users to query the data lake directly without loading the data into the data warehouse. I will go through each of these points in detail in the following slides. New use cases are emerging out of modern data warehouses. NASDAQ in financial services segment, analyzing trading and market data for risk analysis and fraud detection. Pfizer in healthcare segment, analyzing clinical records to improve patient outcomes and predict diseases for preventive programs. GroupM in advertising segment, analyzing clickstream and ad impression logs to improve ad targeting. Warner Brothers in gaming, analyzing gaming behaviors from gaming data. And Hilton Hotels in travel and hospitality, creating personalized offers and experiences for customers. Here are some of the customers currently using Amazon Redshift: Sling, Coinbase, Pinterest, Equinox, etc. More than 10,000 customers collectively processing 2 exabytes of data per day with Amazon Redshift. Amazon Redshift is the fastest cloud data warehouse. Amazon Redshift delivers fast query performance on datasets ranging in size from gigabytes to exabytes. Redshift uses columnar storage, data compression, and zone maps to reduce the amount of I/O needed to perform queries. It uses massively parallel processing data warehouse architecture to parallelize and distribute SQL operations to take advantage of all available resources. Amazon Redshift uses machine learning to deliver high throughput irrespective of your workloads or concurrent usage. Redshift utilizes sophisticated algorithms to predict incoming query runtimes and assigns them to the optimal queue for the fastest processing. As concurrency increases further, Amazon Redshift predicts when queuing may begin and automatically deploys resources with the concurrency scaling feature to ensure consistently fast performance. Amazon Redshift uses result caching to deliver sub-second response times for repeat queries. It is 10 times faster than 2 years ago. More than 200 features and enhancements delivered in the past 2 years based on lessons learned from processing over 2 exabytes of customer data every day. Amazon Redshift is the most cost effective. Redshift is the only cloud data warehouse that offers on-demand pricing with no upfront cost. Reserved instance pricing, which can save you up to 75%, and per query pricing based on the amount of data scanned in your Amazon S3 data lake. ROI over 5 years is estimated to be 469%. At high level, Amazon Redshift cluster consists of a leader node and multiple compute nodes. The leader node manages communication with client programs and all communication with compute nodes. Redshift's leader node creates query execution plans using machine learning and cache query results. Based on this execution plan, the leader node compiles code, distributes the compiled code to the compute nodes, and assigns a portion of the data to each compute node. Compute scales to handle high concurrency, and storage scales to exabytes of data in Amazon S3 data lake. Redshift Spectrum, a feature of Redshift, enables you to run queries against exabytes of data in Amazon S3 without having to load or transform any data. You can use S3 as a highly available, secure, cost-effective data lake to store unlimited data in open data formats such as Avro, CSV, JSON, Parquet, and more directly in S3. This gives you the flexibility to store highly structured, frequently accessed data on Redshift local disks and keep exabytes of structured and unstructured data in Amazon S3 and query seamlessly across both to provide unique insights that you would not be able to obtain by querying independent datasets. You can use other services integrated with S3 data lake, such as Amazon Athena, a serverless interactive query service to analyze data in S3 data lake using standard SQL language. Amazon SageMaker, a fully managed service that enables you to quickly and easily integrate machine learning based models into your applications and can train your model and generate predictions. Amazon EMR, Amazon's Hadoop as a service platform to run big data use cases on the data lake. Here are some of the common use cases with Redshift and our partner Looker. The configuration that you are looking at is the most popular design pattern that delivers agile business intelligence to derive business value from variety of data quickly and easily. Raw data from corporate data applications, sensors, and logs will be loaded into Amazon S3. Copy the structured data into Amazon Redshift and query data in open formats such as Parquet, ORC, and JSON directly from S3 using Redshift Spectrum and analyze data across Redshift Data Warehouse and S3 Data Lake. Using Looker or Amazon QuickSight, you can get insights from your data. Or you can use another service called AWS Glue that can scan your S3 data using Glue crawlers to build Apache Hive compatible Glue metadata catalog, and external databases in the Glue catalog can be queried using Redshift Spectrum without loading data into the data warehouse. And you can run predictive analytics. This is another use case that go over that using Amazon Redshift and Looker. Ingest raw data sets from multiple sources into Amazon S3 data lake. Transform unstructured data in Hive with user-defined functions. And enrich structured data in Redshift with additional columns. Combine these two data sets using Apache Spark. Write back the enriched data to Amazon Redshift. Store these training data sets into Amazon S3 data lake. Train the model using Amazon SageMaker from S3 and get your predictions. Or Looker has an active hub integration with Amazon SageMaker. You can use Looker to create a query, visualize and filter the data, remove any outliers, reshape the data, and then choose the active hub integration with SageMaker. Choose an algorithm for model training such as XGBoost, and choose a location in S3 where you would like your model to be stored, and then run SageMaker to train the model. Once the model is trained, point the Looker to the trained model and send over a set of predictive features from a Looker query. Get a result set dropped back into S3 that can be queried via Redshift Spectrum or Athena, and see model metrics such as precision, accuracy, MAE, and others on a Looker dashboard. Explore and visualize everything in Looker. And the third use case is real-time streaming analytics. You can stream billions of small messages to Amazon Kinesis data analytics and calculate key metrics, which you can then use to refresh content performance dashboards using Looker in real time and improve content performance. So the workflow is you stream the data to Amazon Kinesis Firehose delivery stream, which collects the data and sends it to Amazon Kinesis Analytics. Amazon Kinesis Analytics calculates key metrics in real time to improve content performance and writes the data back to Amazon Kinesis Firehose. Amazon Kinesis Firehose loads processed data into Amazon Redshift. Looker can read this data and provide personalized content suggestions. With this, I'll pass over to Daniel Min, Chief Data Evangelist from Looker.
Thanks so much, Srinivas. I'm going to talk a little bit about Looker, and just for folks who aren't super familiar with Looker, give you a sense of what Looker does and really where Looker came from in terms of why we were founded. And then I'm going to bring on our main speaker, Caitlin, to talk about how Indiegogo is using Looker in AWS. So I think the main thing to know about Looker and the Looker sort of perspective on the world is that most data, for the history of people using data in business, most of that time databases were a blocking factor because they were really slow, they were really expensive. You spent most of your time trying to protect the database from your users lest they overwhelm it. But with the advent of big data and with the cloud MPP databases like Redshift and things like Athena, databases today are not slow and expensive. They're ridiculously fast. They're really cheap. They're really easy to set up and maintain. And that is just a very different world than the one that most people were used to working in. And so that's great. Now all of a sudden you can process huge amounts of data very easily, very quickly for very little money. But the problem is the analytics tools that people are using to access that data, for the most part, haven't actually changed. They're the same old analytics tools that people have been using for decades in a lot of cases. And just like if you bought a Tesla and you were upgrading from your Civic, you wouldn't choose to, keep the tires on from the Civic because, hey, they're still in pretty good shape. Maybe I'll put those tires on my Tesla. That doesn't make a lot of sense, right? You're spending the money on the Tesla. You want to get all of the value from the Tesla. And so if you're making the commitment to upgrade to one of these incredibly fast, incredibly cheap databases of today, keeping the same old tool on top is not a good way to save money. It's a good way to make sure that you don't actually realize the value that these databases give you. So, what we see out talking to, thousands of companies is that when they try to put these old analytic tools on these new databases, they run into one of two problems, or if they're really unlucky, they run into both of them simultaneously. On the one hand, a lot of the time what happens is that the small group of analysts who serve the whole company are the only ones who can access data. And so anyone who wants access to data has to wait in line. And that's frustrating. If I come to an analyst and I say, hey, I need to make a decision this afternoon, and I'd love some data to inform my decision. And the analyst says, well, I don't have time right now, but I can get back to you next week. What am I going to do? I'm going to make the decision without data, right? I can't wait. I have to make the decision this afternoon. So that bottleneck is a real impediment to good data-driven decision making. On the other hand, what often happens is that people get frustrated with that bottleneck. They get frustrated with waiting for the analyst to give them access to the data. And so what they do is they ask the analyst once and they say, hey, can you just carve off a bunch of the data? I know I can't fit all of the data that's in the warehouse on my laptop, but I can get enough of it that it can be useful to me. And so so they take that data and they put it on their laptop or their departmental server, and they put a workbook analytics tool on top of it. And they slice it and dice it, and they're doing well. They can make sense of this data, they can get access quickly, and that seems great that they're not stuck behind that bottleneck. And it is great until they get into a room with their colleagues who also sliced off a chunk of data and took it onto their laptop and tried to make sense of it themselves. And so, you get into the meeting and sales says, hey, sales are up, they're through the roof. And marketing says, no, they're not, they're down. And finance says, actually, guys, they're flat. And now you can't spend your meeting, planning your strategy for next quarter like you're supposed to be. You have to spend your meeting and probably, the days after your meeting trying to figure out whose data is right. Where did everybody get their data from? How did they interpret their data? How did they change their data in their workbook? How do you trace that back, right? And so you just have chaos because nobody can agree on what the data means. So, those two problems are fundamentally driven by not having analytics tools that can really take advantage of today's best technology. And so Looker comes at this this problem with the perspective of, well, most analytic systems were designed where the main constraint was the speed and the price of the database. So what would we actually design if we weren't constrained by the speed and the price of the database? Well, we'd want to solve both problems, right? On the one hand, we would want standards and governance where we agreed across the company on what our key metrics were and how they were defined. And on the other hand, we'd also want people to be able to self-serve. We'd want to have agility to keep up with the changing nature of today's business. We'd want flexibility. And so Looker is aiming to solve both problems. That's our goal, right? To give you the standards and the governance while maintaining the self-service, the flexibility, the agility. So let me talk quickly about how we do that. First, we make sure that there's a single source of truth, that Looker becomes the single source of truth. And we do that with our really unique, I would say, modeling layer, our semantic layer. And for those of you who have been in BI for a long time, you may be familiar with semantic layers from older school products. Looker's approach to this is really fundamentally different than really everybody else on the market. Looker uses LookML, which is our modeling language, which is just an evolution on SQL. It's based on SQL because we know that just about every analyst out there speaks SQL, but it deals with some of the drawbacks of SQL, right? SQL is wonderful, it's powerful, it's flexible, it's ubiquitous, but it's really hard to keep track of SQL. You end up with a bunch of text files on your desktop. It's really hard to reuse SQL, right? If you wrote something more than a day or two ago, it's hard to interpret what you were doing, let alone interpret what somebody else was doing. So Looker and LookML make SQL reusable. They make it collaborative. They make it version controlled. They make it so that you can write little pieces of business logic in SQL, and then Looker takes care of reusing them and combining them in the right ways. And that gives you that single source of truth so that when someone says, hey, I want to see lifetime customer value, as a business user, they don't need to know the specific definition of lifetime customer value. They just need to know that the name of that metric, and Looker takes care of knowing that definition. Second of all, Looker is a modern piece of software that's built, fully in the cloud. There's no desktop version of Looker that you download. It runs entirely in your browser. And what that allows us to do is to plug into the full range of tools that we know that business people are using today. It allows us to send data to you when and where you need it, whether that's Slack, whether that's on your phone, whether that's by email, whether it's by FTP, whether it's pushing it to an S3 bucket. Wherever you need the data, we can put it right in your workflow. And finally, because Looker is built in a way that is modular and that sits on top of the database that you're using rather than sucking the data into our own data store, we're ready for the unknown, right? We know that today's databases are amazing. We know that tomorrow's might be even more amazing, and we don't want to lock you in to a particular technology. We want to give you the room to grow and change as your business needs grow and change. So lastly, let me just show you a little bit of sort of how Looker is structured, and then we'll hand over to Caitlin. So, when we talk to our customers today, just about every one of them comes to us with lots of different data sources. That is the norm. If you're like, well, I have data that lives in a lot of different places, don't worry, you are not alone. That is the way that most businesses are today. People have data from SaaS applications, they have data in their transactional database, and in ERP, web analytics, they have all this data that lives all over the place. And today, it's really easy to centralize that data. It used to be a really difficult heavyweight process that might take months, but today you can do it in an afternoon. There are just amazing partners and services out there that you say, hey, I have data from Salesforce and MailChimp and SQL Server, and I need it to go into Redshift. And they say, great, enter your credentials here, and we will start piping it right now. And so, our customers, what they do is they start piping that data pretty raw right into things like Redshift and Athena, because not only are today's databases more powerful, faster, cheaper, they're also much more flexible. They can deal with the raw data. You don't need to do that heavyweight manicuring of data and cubing of data before it loads into the data warehouse. So customers pull the data out, they put it into those, they pipe it into those data warehouses, And then that's where Looker comes in. Looker sits on top of your database. We don't have our own data engine that comes with the analytic tool. We use yours because today's databases are so powerful. We want to actually leverage all that power. And we want you to stay in control of your data. We want it to stay in your database. So Looker sits on top. It brings you business logic and governance. It manages your users and your connections. It gives you the ability to sort of scale and extend as you need. And it gives your analysts a place to centralize their knowledge about what your data means. That's what LookML is for. It lets the analysts get all of that knowledge about what the data means out of their heads, because as long as it's locked up in their heads, you've got that bottleneck problem. And it puts it in software because software scales a lot better. And that knowledge then lets Looker write the correct SQL, send it to your database, and bring those results back so that they can deliver them to your users wherever they're needed. So that might look like traditional business intelligence. That's a really common use case with Looker, right? Self-service exploration, dashboards and reports, fully interactive JavaScript visualizations. That's a really normal way to use Looker. And for most BI tools, that's where things end. But Looker is a data platform. It's not just a BI tool. So you can do a lot more. You can also embed data from Looker directly into your workflow, whether that's in other applications or in your own custom applications using iframe or our JavaScript embedding. And you can pull data through Looker into your existing workflows. So whether that's using our schedulers or our full 110% coverage of our RESTful API, whether it's pulling it into messaging applications like Slack or sending it to outside services like Zapier via webhooks that can send it on to literally thousands of other destinations. And the advantage of doing this all through Looker is that no matter where you're using the data, no matter where you're asking the questions, you're always getting the same answer to that question. And that's really critical to prevent that chaos. So with that, I'm going to bring on our main speaker, Caitlin Moorman from Indiegogo, to talk about how Indiegogo is using Looker and AWS to power their analytics.
Great, thanks, Daniel. I'm Caitlin Moorman, and I lead the analytics team at Indiegogo. We are a platform that enables new products to take flight. So we are connecting entrepreneurs with early adopters to raise funds, get early feedback, and bring their products to life. We have a small centralized data team that supports the company. And so my team needs to analyze user behavior and event data, sales and marketing data, transactional and financial data, operational data. If we have it, the company is generally looking to my team to derive insights from the data. We've got 3 or 4 analysts at various points to support in the ballpark of 100 employees. So before we combined Looker and Redshift at Indiegogo, we had a bit of a mess on our hands. We were one of those very unlucky companies that Daniel mentioned that suffered from both the bottleneck and the chaos. We were reporting out of both Redshift and MySQL from a copy of our transactional database. And we had built some ETLs in-house to bring some data from our primary SaaS tools like Salesforce, but we only had access to a portion of the data from those tools. It all lived in our MySQL database. And we did some transformations of data via those ETLs, but the definitions of most core segments lived directly in our reporting layer. So on top of those 2 databases, we were using a pure SQL-based dashboarding tool. Every query was independent. So if we changed a definition, my team had to go in and find every query where the logic was used and manually update it, which was tedious, very manual, and often error prone. So we created this chaos for ourselves. Even my team contributed to the chaos because of this. So we knew the definitions, but we didn't necessarily enforce them. So there was inconsistent data. Sometimes within a single dashboard, you would have conflicting information. And a lot of just frustrating audit work for my team. We didn't have a single source of truth for metrics definitions. Documentation was really limited. So if we did have users outside my team who were comfortable writing SQL, they likely didn't really know where to start. So because we had this stack that didn't prioritize usability, our analysts and data engineers had become bottlenecks. Business stakeholders needed analysts in order to access even basic data, because most of them weren't comfortable writing SQL. Those that weren't comfortable that they were writing the right SQL. Our homegrown ETL required a lot of manual maintenance by our data engineering team. And even with all that manual work, not all of our data sources were available. So for some projects, we had people manually pulling data from multiple sources and trying to bring it all together to get a holistic view. And all of that manual work limited the ability of our analysts to focus where they really added the most value, which was actually working hand in hand with stakeholders on impactful analyses, following through with recommendations, really working with the data, not just getting people the data. And then on top of that, we also had some significant performance challenges. So we did use Redshift primarily for our event data, but a large portion of our reporting was coming directly out of a copy of our MySQL transactional database. Those queries could get really slow. And when we did use Redshift, we weren't able to enforce best practices, basic things like joining on distribution keys, filtering by sort keys. So we had a lot of performance issues, and generally what the performance we saw with Redshift wasn't in line with what we knew was possible. So as a result of all of that, basically everyone was frustrated. Our data team was frustrated by how much time they spent on tedious, low-level tasks. Our stakeholders across the company were frustrated by how long they had to wait to get a simple data request from us. Everyone, but most visibly the exec team, was frustrated by the conflicting data and the lack of visibility due to inconsistent definitions. And everyone was frustrated by just sitting and waiting for a slow query to finish. So we cleared the slate and we set out to fix the mess we'd made. We wanted to find solutions for four main needs. We wanted to consolidate everything into a single data warehouse for analytics. We wanted to implement a SaaS data pipeline that can consolidate all of our data sources into the warehouse so that we actually had access to everything and could create that robust consolidated view. We wanted to empower our analysts to transform data without support from engineering so that we could create more analytics-friendly views without then having to rely on data engineering every time we wanted to change something. And we wanted a user-friendly front end so that we could have our business users actually go in and explore data, but without sliding back into the chaos. So here's where we came out. We consolidated all of our data into Redshift. We already had our event data coming into Redshift via Amazon Kinesis, and then we used Stitch to replicate our MySQL transactional database into Redshift, as well as a range of SaaS tools we use. So we now have access to all of our data from Salesforce, Stripe, HubSpot, AdWords, Facebook ads, Zendesk, Google Analytics, everything that we use. And that is really a game changer for our teams. We added Matillion ETL on top of Redshift, which lets our analysts transform data into more analytics-friendly tables within Redshift. It's all SQL-based. They're very comfortable writing those transformation jobs. And then all of our reporting comes out of Looker. Looker's modeling layer helps us document as we go. It helps us enforce correct metrics definitions, and if we change them, to enforce that change across the board. The front end allows business users to access data however works best for them. For a lot of them, that is within Looker's UI. They build dashboards and go back to that dashboard. A lot of people use emailed reports. Some people access it via Slack. And then we have a range of things that people do with the data via Zapier. So they're updating data directly in a Google Sheet. They're sending it into another tool. and they can really leverage the data however works for them while still having confidence that they have the most up-to-date definition, that their data will align with another team, and that we really sort of resolved the chaos. So since we've implemented these changes, we've seen just a huge change in how analytics works at Indiegogo. We eliminated the vast majority of routine data engineering tasks. So instead of having basically 3 full-time people focused on internal data support and sort of chore load, we now have no full-time internally focused data engineers who are primarily working on those internal chores. They're off in product teams working on much more exciting substantive work. Our analysts are able to support all of the routine changes or improvements, and we partner with engineering only on bigger, more interesting projects. We were able to double the number of third-party tools with data available for easy analysis. And the tools that we had already had access to, we significantly lowered the latency of that data, so everyone has access both to more data and more up-to-date data, and can get that bigger picture of what's going on throughout the company. On the performance front, we improved our average query speed by about 40% just by enforcing the use of Redshift, enforcing performant joins within Looker's modeling layer. And that sort of understates the impact on those really painful, very long queries. So it's very rare for us to ever see a timeout. If someone's doing that, they're doing something wrong. They're trying to bypass our restrictions, but it's really been huge in terms of how quickly people can access what they're looking for. We empowered everyone in the company to easily explore data. So they don't need to know SQL. They don't need to know the definition of a metric. And they can see documentation within the tool. So if they're exploring, they can see a definition of a metric right there and make sure that they're actually analyzing what they're trying to. The drag and drop exploration within Looker is so simple to use that we've dramatically decreased the number of basic requests that come into my team. The ones that do come in are super quick to finish and often accompanied by, hey, let me show you how to do that so that next time you don't have to ask us. And that enables our analysts to focus much more of their time and effort on high impact analysis, proactive investigation, predictive work, the things they really want to be applying their skills to, and where the company really gets a lot more value than writing a very simple select this metric by month. Choosing the right tools has really just allowed everyone in our organization to kind of move up the stack. So we're using people's skills and resources more efficiently. It takes less time to go from having a question to getting a real data-driven insight. And I think kind of my favorite part personally is that we just see a lot better collaboration around data. It's really easy to share links via Looker. So if you're in the middle of something and run into a question, you Slack the BI team, ask them, hey, am I on the right track here? They say, oh, almost. Here, let me make one change for you and send it back, and now you're good to go, and you keep heading down that path you were on. Those easy handoffs, those really simple moments of, hey, I got to this point, but what do I do next, really allow everyone to get to their questions answered faster, get to the next more interesting question faster, and really help the business make better decisions. It's been 2 full years since we implemented this combination of tools, and we've been super happy with the results. I am so excited to say that in 2 years we haven't yet devolved back into chaos. And both the analytics team and the company as a whole are just really delighted with the results.
Great, thanks, Caitlin. So I have a few questions, if that's okay.
Absolutely.
Because I love this story, and I don't mean to, traumatize you by taking you back to the old terrible world of 2+ years ago, but I do want to sort of dig in a little bit on what the sort of impact on the business was, to sort of not being able to use data, confidently. What was that like? What were the sort of business outcomes that you saw from that, where, you talked a little bit about the chaos. I'm curious sort of how that impacted the business at the bottom line.
Yeah, absolutely. So a number of our key business segments were really just written right in raw SQL in every dashboard, every segment of every dashboard that we were reporting on them. And so that was even things down to, the business lines by which we manage the business. So this team owns this line, this team owns this line. And if we changed sort of where that boundary was and changed the definition of those segments, we had to go in and manually update everything. And that was often a lot of different views of the data. So we would then end up with a couple of stragglers where it didn't get updated, places where we had two conflicting points of view, or worse, places where something was invisibly wrong. There was no conflicting point of view. It looked correct, but it was not. And so, if you are the owner of a business line and you see that you're not on track to hit your target, you panic and you muster a lot of resources around what are we going to do? How are we going to close the gap? What actions are we going to take? Why did this, why are we suddenly not on track? And so when that happens, but it's actually because of a data error, you get a lot of confusion, a lot of frustration, a ton of wasted time, both investigating the discrepancies and worse, not investigating them, just responding to them, because you don't realize they're a discrepancy. And over time, people just stopped trusting the data. We had one dashboard in particular that was so painful. It had so many separate queries, and inevitably the data on it didn't align somewhere. And it was a really important dashboard. It was like our key forecasting dashboard, and people just stopped trusting it. They just stopped thinking that they could go there and get information independently and make a decision on it. They would go and they would look at it, and then they would either decide they didn't want to make a decision based on it at all, and they would make whatever decision they wanted regardless, or they would reach out to the BI team and say, hi, I saw this on the dashboard. Is this true? Can you double check it? Can you look at it for me? And again, that's just a bunch of wasted time. It was not great.
Yeah, no, that definitely sounds not great. I mean, I like the expression that tech fails noisily, but data fails silently, right? If your website goes down, I mean, monitoring is good. It'll tell you a little bit faster, but I promise you, someone's going to be knocking on your door if you run the website pretty darn quick to mention that the website is down, right? But when data fails, as you said, it's often silent. It's often there in the background, and if you're lucky, it fails in a way that you sort of scratch your head and you go, that can't be right. And if you're unlucky, it looks reasonable, and so you go with it, and you make business decisions based on it. And then 6 months later, you realize, oh no, that like key metric that we were making all our decisions on has been wrong the whole time. That's very nerve-wracking. It's very scary. So tell me a little bit about sort of what the implementation was like. How long did that transition to the new way of doing things take? Was it, a many months long project? Was it something where you sort of worked on it all at once and then rolled it out on one big day? Was it something that happened incrementally? Just curious what that looked like.
Yeah. So despite all of the limitations and chaos within our prior system, we did have really robust use of our prior dashboarding tool. So effectively everyone in the company was using that tool for at least one report somewhat regularly. So when we looked at the migration, it seemed like a very daunting task. But we're an agile organization. We don't do anything as a single rollout. So we broke it down as best we could to figure out kind of what are the chunks that we can get out and help get people going as quickly as possible. So we started with all of the back-end work, the things that really primarily affected the analysts and data engineers. We got all of our existing data and all of our new data sources available in Redshift. We built out a very basic model in Looker so that we could start to build out just a couple of dashboards that are kind of the core company reporting that just shows like, hey, overall, here's how we're doing. Here's how we're pacing against target, things like that. And kind of tested the waters with those. And that whole process was probably a few weeks to get to that point. And once we had those bones, we wanted to roll it out to the rest of the company pretty thoughtfully. Our biggest driving force was that we really wanted to make sure that everyone who went on to Looker early became a really strong advocate for it, so that the rest of the teams would look forward to the migration instead of dreading it and thinking it was this big distraction and another, thing on their plate. And we also just wanted to keep the overall company-wide timeline manageable so that we didn't pay for 2 tools longer than we needed to. So we started with our sales team. They had the most issues with limited access to data. Obviously, they were big users of Salesforce, but we only had, a handful of fields available from Salesforce opportunities, and like nothing else from Salesforce was available. They had to do all of their other reporting within Salesforce. So we worked with them to figure out what they were using in the old tool, what reporting were they actually looking at, what worked for them and what didn't on those reports, like what did we just not need to rebuild because no one ever looked at it. They nominated a couple of people to kind of be the point person for that, the people who were most data savvy. So we worked with them to kind of make any revisions we needed, make sure that what we were going to build would meet their needs and kind of understand what the requirements for it were. And then my team worked all together on a 2-week sprint to build out everything that we needed within Looker. So the models that we needed, the dashboards that we needed, training the new team on how to use Looker, just the basic sort of here's what you can do from a dashboard, because it's not like other tools where what you can do with a dashboard is look at a dashboard. It's a jumping off point to a lot of other things. And so as we built that out, we made sure that we met their basic needs, but also wanted to make sure that we were identifying places where we could kind of add some bells and whistles that leveraged Looker's functionality. So whether that was like an individual performance dashboard that automatically filtered based on who you were when you came to the page, or an email alert that would let you know as soon as a campaign crossed a meaningful milestone, or for that matter, let you know when a campaign launched, because we don't always know that. Our sales team doesn't really know when things are going to actually go live sometimes. Links so that people could go directly from a dashboard into our application or into Salesforce and go straight from, oh, this looks interesting, let me go look at what's going on within there. And those little things helped optimize their workflows a little bit, but the more important thing for us was just to get people excited about it and help them realize that they have a lot of new options. So when they thought of something that would be useful or would make their life better, they would actually come to us and say, hey, how do we make that happen? How do we get this this link put into Looker so that when I look at a list of my campaigns, I can go immediately take this action. And then once they were trained, we cut them off from the old tool completely, really quickly, forced them to fully transition and made sure that everybody was ready to go. So we basically went through that same process for every team, prioritized them based on who would get the most benefit from Looker or from the new data sources that we had, or from the whole process. And then we accelerated a couple of teams that were sort of brand new and didn't really have reporting. So we time boxed each team. That enabled us to make it through the full transition in about 6 months from starting to really build out the back end to getting everybody off the old tool. And there were a few things that because we were time boxing each team, they would have a report that one person used once a quarter. We would just put it in a backlog, and we did a big cleanup at the end that took another couple weeks to get those little stragglers done. But for us, the biggest key was finding those advocates who were really excited about it. They got other people excited about it. They were also usually the ones that were authentic enough to tell us when something didn't work so that we could fix it. And just making sure that we had that open line of communication with people as they came on board was really helpful.
Yeah, I love that. I mean, I particularly love the sort of focus on people, right? The recognition that, technology change is not actually enough to drive organizational change, that it really is about the people, and thinking about who can be the advocate for this new tool, who can, tell their colleagues, who's the sort of trusted advisor and can tell their colleagues in the department, oh no, no, you definitely want to get on the new stuff. It's so much better. It's going to make your life so much better. That coming from somebody who sits next to me is much more powerful than coming from a department that I only interact with occasionally, right?
Yeah, absolutely.
And so I love that focus. So I just have one last question, which is you mentioned that there were, before world, you were pretty reliant on engineering and a crew of data engineers to do a lot of sort of munging of the data, any sort of changes to the transformation. You really needed them to take the lead on that. And now they're not doing that. I'm curious just how they feel about that. Is that something that they're happy about?
Oh, they're ecstatic about it. So we, for a long time, had a small engineering team that was specifically dedicated to kind of internally focused data engineering. And sometimes they worked on really cool, exciting projects, but they also had a huge chore load where they just spend time going in to change an ETL to bring in a new table that some other team created, or to change the logic in a particular metric, or just to do things that were not particularly interesting. So we actually no longer have an internally focused data engineering team, and those engineers instead are dispersed into other product teams. So they work on all kinds of stuff. Let's say they work on things like our payments architecture, our user-facing analytics tools, so the analytics that our campaigners have access to while they're running their campaign. They've done some really cool production machine learning work, site performance improvement work, and just your average user-facing feature work. They're really happy. They do periodically still work on internal data projects, but it tends to be those more interesting, meaty projects. They don't have this annoying chore load that eats up most of their time.
Got it. I like that phrase. I'd never heard that before. Chore load. That definitely captures the sort of pedestrian nature of it, and the probably lack of fun that they were having with that.
Yeah, absolutely. They had about as much fun as my 9-year-old does cleaning the table. Like.
Got it. Yep, that captures it. Awesome. Well, thank you so much, Caitlin. I'm going to pass it back to Srinivas just to tell you where you can get more information, and that will wrap us up. Srinivas.
Thanks, Daniel. The next steps are like to learn more about AWS data and analytics. Please go to this link, awsamazon.com, big data, data lakes and analytics /partner solutions. To learn more about Looker on AWS, go to looker.com partner network /Amazon web services. Looker free trial can be obtained at looker.com demo and AWS Redshift trial. To try AWS for free, you can register yourself at aws.amazon.com/free. Again, thanks everyone for joining. Thank you.